and then share again. Hi, David. Welcome to the class. Okay, so today we're starting with what a probability experiment is. I'm just going to zip through a lot of these. Okay, a probability experiment is one trial of a experiment involving chance. An outcome is one possible result of a probability experiment. And a sample space is all possible results of a probability experiment. A tree diagram is a visual tool that shows you the sample space. All right. So if I start drawing a tree diagram for this, the important thing, which this is somehow something that people always don't get right. You start with one of the experiments and you're supposed to do them in order. So like, for example, the first thing we're doing is rolling a die. So I'm going to write down 6 numbers. 1, 2, 3, 4, 5, 6, because that's how many numbers are on a normal die. And then branching off of each, is heads, tails. So if I was going to make a list of all the things that were in this, I'd say you could get a 1 heads, going down my list, 1 tail, 2 heads, 2 tails, 3 heads, 3 tails, etc. Looks like 12 different options. Okay. Sometimes an event has more than one outcome. If it is, then it's complex. And if it doesn't, then it's simple. For example, asking a student her age, if she says 20, there's only one way that she can say that, by saying 20. She says, I'm 20, that's it. Like, it's not like, oh, if she says 22, I'm also going to count that as 20. Can somebody tell me why this one is complex? Getting at least a 4 on a 6-sided die? Just unmute and say something, or just talk to me. Right, at 1, 2, 3, 4. Well, it says it's at least a 4. So it actually would be, you could get 4, 5, or 6, right? That's why this one is complex and not simple, because there's multiple things you could get that would fall into that category. Can you tell I really tried with these notes to make them complete? The fundamental counting principle says that if one event can occur in X ways and a second event can happen in Y ways, then the number of ways that they can occur in sequence is X times Y. And remember, if you're trying to copy this all into your notebook and getting overwhelmed, you can just ask me for a copy later in school, or you can go back and watch this video slowly if you need to. So you're purchasing a new car. You have a choice of 4 manufacturers. So I'm gonna write here, this is like the manufacturer. And it says we're gonna multiply because it's this and that. You have 2 choices in car size. So this is size. And then we have 5 choices in color. So since there are 4 choices of manufacturing, 2 choices in car size, 5 choices in color, that makes 4 times 2 times 5, which is 40 options. And if we had made a tree diagram, it would have looked like it would have been like, okay, so we got Ford and GM and then like Honda and Toyota, right? And then off of each one of those, it would say like a subcompact and with a sub, it was compact and midsize. So compact and midsize CM, right? Off of each one. And then off of each one of those, you would have had 5 colors. So each one would have been 5 off of that, like this, kind of like going down. And so if you started wanting to list them, you would say, okay, this is the example where I have a Ford, it's a compact, and it's white. And then you could kind of go down those branches and list every single one, and there'd be 40 of them, which isn't worth your time when you can just multiply 3 numbers and know how many there are. Next page. Are we okay moving on? Okay. Access code for a security system is 4 digits. All right, each digit can be, how many access codes are possible? They can be from 0 to 9. Each digit can be only used once and not repeated. All right, let's do this one together, and then I'm going to give the other 2 for somebody for a prize. So we got 4 digits. How many choices do we have for the first digit?
9.
10, because that includes 0, right? You got 1 through 9 and 0.
Okay.
Okay, but then the next one is the first digit, but the next one you can't have whatever repeats. So let's say you use 7 on the first one, then you can't use another 7. So how many choices are there now?
9.
9, 8, 7. Can you imagine how miserable that would have been to make a tree diagram for? Because if you take 10 times 9 times 8 times 7, turns out it's 5,040 choices. All right, your turn. You do the other 2. Raise your hand when you want to tell me what you got for a prize. All right, Krista's got her hand up. You want to go or no? Yeah? All right, so Krista's 1 and Tanner's 2. Krista.
The first one you do 10 times 10 times 10 times 10, which is
Good.
10,000.
Good. Totally right. Keep going.
And then the second one you do 8 times 10 times 10 times 10, which is 8,000.
Good. Perfect, Krista. You want to see those animals or you want I'm winner?
I'll look at the animals.
We got an elephant and a tiger and a bear and a camel and my favorite animal, a rhino.
I'll do the tiger.
All right. All yours. All right, now for the next section, anybody have any questions for me on example 4? Are we good there? Okay. The next section just talks about the 3 types of probability. Classical, also called theoretical. You can use math to figure this out. No experiment required. This is like a dice or cards, anything like that. Empirical is based on observations obtained from data. So if you have like info from the past, like this is how often people have been struck by lightning in the past, and what are the chances it'll happen to you in the future? You probably should look at that data. If I said, what are the chances you'll be hit by lightning this year? You don't want somebody to go, I don't know, 2/5, you know, like that's just a weird random guess, but you definitely want somebody to be like, well, last year was 7 out of a million people or something. So subjective, that's an educated guess. That's like a weather report. They understand, I mean, they are using information about the past, but not directly. You know what I mean? Like, I'm not saying, if I say to somebody, is it going to be sunny today? They're not going to say to me, well, for the last 30 days, 20 out of them were sunny. So I give it a 2/3 chance it's sunny today. Like, you don't need, you want to look at weather patterns and that kind of stuff, right? That's the educated guess part. Law of large numbers. As an experiment is repeated over and over and over, the probability of an event approaches the actual probability of the event. Did we do this in my last stats class? Did we do that thing where I had you like pretend to roll a dice on your calculator like 100 times and count how many whatevers we got? That's a shame. That was a fun thing. Okay. So here's what this means. Let's say that you rolled like 100 die. And you rolled 100 die, maybe, I'm just going to talk about it for a little bit. Maybe you'd get like, for 1/6, we expect that like on a die, you would get a number 2, a 1/6 of the time. But if you rolled it once and you didn't get a 2, then I would just look at your experiment and say, oh, I guess you never get a 2, right? But if you rolled it 10 times, maybe you'd have like a 2. And then I'd say, it sounds like the probability of getting a 2 is 1 out of 10. And then if you rolled it 100 times, maybe you'd be more like 15 2s, and I'd be like, okay, so now the probability is like 15 out of 100. And so the more times you do it, the closer it gets to like 1/6, like exactly what you would think. That's what law of large numbers is. The range of probabilities is anywhere between 0 and 1, because 0 is 0% and 1 is 100%. Complement of an event is finding the opposites. Of an event. And then subtracting from 100%. What's the probability of not getting 2 numbers that add up to 7 when rolling 2 dice? All right, does anybody remember from my past class, how many possibilities are there for rolling 2 dice?
36.
36, 6 times 6, right? 6 on the first die, 6 on the second. So now what we would do is you'd think about all the different combinations and you'd say like, okay, well, 1 plus 2, that equals 3. That's not 7. That's one of them. What if I got like a 3 and a 3? Okay, well, that makes 6. That's not 7. You see how like this would be so tedious because we'd have to write out so many of them. So instead, what we can do is we can say, all right, if I get a 3 and a 4, that makes 7. And if I get a 4 and a 3, that makes 7. We could get a 5 and a 2 or a 2 and a 5. A 1 and a 6 or a 6 and a 1. Any other options? No. So that's basically a 6 out of 36 chance of getting a 7, right? So what are the chances of not getting a 7 then? 30 out of 36. So you see how I'm kind of like subtracting from the whole? That's called a complement when you figure out the opposite of what you want. Because it's faster. Conditional probability, that means that finding a probability when something else has already occurred. Probability of B given A, so this means probability of B given that A already happened. Okay, I think right now, because this is kind of like a, this was a bit of a challenge. Going back, remembering all the probability. Do you guys agree? Like, how are you doing with this? Are you like, oh, it's easy, or like, man, I'm gonna need a little bit of practice? Mitchell gave me a thumbs up. Michaela, Megan, how you feeling? Krista? I know, Megan, I thought you thought that like this chapter was the hardest of the 3. Krista, how about you?
It's good.
Okay, Michaela?
It's fine. Like, it's just taking me a little bit longer, but I should be fine.
All right, so here's what we're gonna do instead. I'm gonna call it a day. Just getting through half the notes, and we're gonna do the second half tomorrow, okay? So your homework, which I still want you to do, because we'll still go over the answers. If you turn to the very back page, your homework is page 142 through 56. It like on every single problem, this is just finding probabilities, so the problems go really fast. It's stuff like 8 times 10 times 10, and you write down the answer, you know? So the problems go really fast, but also like every single problem says, give an explanation. I don't need an explanation for anything, okay? I just need you guys to do the math. I'm not gonna actually have a Dropbox for this tomorrow, because I'm gonna wait till both of them are together when we finish both assignments, and then we'll turn them in together, okay? Okay, anybody have any questions for me for those first 2 pages we did, and we'll do the second 2 pages tomorrow? Or maybe Friday if we have a huge snowstorm. Yeah, we're supposed to get 3 to 7 inches. But it's starting at a weird time. So if it hits 3 inches and if it starts at like 6 a.m., I don't know if anything's going to change or if we'll get out of school early or how that'll work. But anyway, so everybody online good? All right, I'll let you go for the day. Bye, guys. Yes. Good. Oh, you did every single question. I'm proud of you. Yeah. When are you gonna do that? Good luck. You have a calculator of mine, right? That you can use? So do you need one for the weekend? Okay, you can take one of mine if you want.
I'm assuming I can't just bring my phone in there and use that.
No, no, absolutely not. Yeah, they'll definitely give that a hard pass. Mitchell, you got a question for me? Oh, you want to talk about that standard deviation one, right?
Yep.
Okay, give me a problem to look at, please.
Still recording if you want to stop, it's up to you.
Good point.